Hey guys, we're going to take a look here at this is called the Moving Man's Colorado FET simulation, but it can help us kind of visualize what's going on with actual movement and our position time and velocity time graphs. All right, so we have our position time graph here, we have our velocity time graph here, and so we can actually do a few things with this and kind of see what happens, how it affects the graphs. Right, so I'm going to start by just going +1 meters per second, and I'm going to move. We see that I am going at a constant velocity, so I got a horizontal velocity time graph. And I'm also moving away from the origin, that 0 meter mark, and I'm in the positive direction. I'm going to the right. The right is positive. Now, why is the right positive? Simply because that's how it's set up. I could have reversed it and said to the right's negative and to the left is positive. It doesn't really matter. It's just whatever you decide, you just need to be consistent with that problem. Most of the time, people say to the right's positive, to the left's negative, which is kind of what they're doing now here. But let's say right now he gets this far and says, you know what? Let me think for a minute. And now he just sits. So now his position is remaining the same as time is going by, but his velocity, we see, went down to 0. Now, in our graphs, you don't need to connect it like this. It's just going to go directly underneath it, so there could just be, no red line connecting it, and that would be fine. But we see here it's a constant velocity of 0. Let's say you decide, you know what, I need to go back to where I came. We're going to go -1 meters per second. The negative just tells me I'm going left now because we said left is negative. So that's only telling me the direction that I'm going. All right, so they're heading back there, and we see now I'm heading back towards the origin. I have a negative slope. I have a negative velocity. All right, and he stops right there. But we'll go real fast here. We'll say going 6 meters per second to the right, and whoo, he's moving. All right, so now we see a big jump here. Again, you do not need to connect the lines here. You can just have it end here and then start up here. Even though in reality there's a change in velocity, we're not dealing with that now. That's our next unit, so just ignore it. All right, so you can just do a straight line, not connect them, and then another straight line. So now he's going faster, still going at a constant velocity, and we see that the slope of each of these lines is different. This is 1 meter per second. It's kind of shallow. And this one's 6 meters per second. It's a lot steeper because the slope of this line would equal 6, and that's faster. So that's the slope of a position time graph tells me the velocity. And you can see that here. A shallow slope means I'm not going that fast. A 0 slope means I'm not moving. The shallow in the opposite direction tells me I'm going slow, but now going in the opposite direction, so it's negative. And then a steeper slope, it's a positive slope, tells me I got a positive velocity, means I'm just moving to the right. All right, so that is all that stuff means. All right, hopefully that helps and clarifies things a little bit more.